The golden sun above the horizon, a beautiful moon in a scary night. There are many natural objects in this world that has the same figure. Even man-made objects like balls, cup, plates, ring, and manual are developed with the same figure. What common shape is being illustrated in this object? Circles, right? Here we are going to explore the real-world facts about circles. This video brought to you by
Group 2.
Hi, my name is Azri Ameera.
Hi, my name is Najwa binti Sufyan.
Hi, my name is Annisa Aishah binti Muhammad Muzaha.
Hi, my name is Muhammad Syahmi bin Zari.
So, what is circle? A circle is formed when the plane is parallel to the base of the cone. Its intersection with the cone is therefore a set of points that is equidistant from a common point, which is the central axis of the cone, which meets the definition of a circle. Next, we will learn the features of circle. One of them is that a circle has a set of all points in a plane that is equidistant from a given fixed point that is called the center, which is CHK. A line segment is determined by the distance from any point on the circle to the center point is called radius, which is r. It is called the Chord Bisector Theorem if we have a circle with center P that contains the chord ML, which is perpendicular to the bisector of ML that passes through point P. There are two forms of circle, which are standard form and also general form. On the coordinate plane, the standard form of the equation of the circle is x minus h squared plus y minus k squared is equals to r squared, where h, k are the coordinates of the center of the circle and r is the radius. If the center is at the origin, which is 0, 0, then x squared plus y squared equals to r squared. Secondly, a general form of the equation of a circle can be found by using the standard form x minus h squared plus y minus k squared equals to r squared. Once we solve the standard form by expanding it, we will be able to get x squared minus 2xh plus y squared minus 2yk plus h squared plus k squared minus r squared equals to 0, where the center hk is equals to negative g and negative f. It will become x squared plus 2gx plus y squared plus 2fy minus r squared plus g squared plus f squared equals to 0. And let c equals to negative r squared plus g squared plus f squared. Hence, the general form that is acquired will be x squared plus y squared plus 2gx plus 2fy plus c equals to 0, where r is equals to g squared plus f squared minus c square root, and c will be negative g negative f. Fun fact, did you know that circle is actually one of the conic sections? The knowledge of conic sections can be traced back to ancient Greece. Menaechmus credited with the discovery of conic sections around the years 360 to 350 BC. It is actually reported that he used them in his two solutions to the problem of doubling the cube. There are two methods to find intersection point of two circles. First is by using the discriminant. When two circles that intersect at one point, we'll be using the formula b squared minus 4ac is equals to 0. Next, when two circles that intersect at 2 points, we'll be using the formula b squared minus 4ac is greater than 0. Lastly, when the two circles that do not intersect, we'll be using the formula b squared minus 4ac is lesser than 0. Other than that, we can find the intersection point of two circles by using distance. For circles that touch each other, we can use either d equals to r1 plus r2 or d equals to r1 minus r2. Next, for circles that cross, we will use d is lesser than r1 plus r2. Finally, for circles that never meet, we can use either d is greater than r1 plus r2 or d is lesser than r1 minus r2. Last but not least, we will know how to find the equation of a tangent to a circle. A tangent to a circle is actually a line that touches a circle at one point, which is actually known as tangency. At the point of tangency, tangent to a circle is always perpendicular to the radius with which it always intersects. If the equation of a circle is x squared plus y squared plus 2gx plus 2fy plus c equals to 0, then the equation of a tangent to a circle at the point P x1, y1 is x1 plus y1 plus g x plus x1 plus f y plus y1 plus c is equals to 0. Otherwise, if the equation of a circle is x squared plus y squared equals to r squared, then the equation of a tangent to a circle at the point of P, x1, y1 is x1 plus y2 is equals to r squared.
In 4a, a circle passes through the origin at its center at the point 3, negative 3. So, given center point of the circle is 3, negative 3. So, we will declare h equal to 3 and k equal to negative 3. First, we substitute the value of h and k into standard form to gain the value of radius. Thus, r equal to sed 18. To find the value of c, we substitute r equal to sed 18
g equal to negative 3 and f equal to 3
into the equation of c. Thus, we will get c equal to 0. And then finally, we substitute the value of g, f, and c into the general form to get the equation of circle C. Thus, we get the equation of the circle C, which is x squared plus y squared minus 6x plus 6y equal to 0. For question 4b, given line y equal to x minus 6 meets the circle C at the point P and Q.
Substitute y equal to x minus 6 into the equation of circle that we got in 4a.
And then we solve and factorize 2x squared minus 12x equal to 0 and get x equal to 0 and x equal to 6. If x equal to 0 and y equal to negative 6, if x equal to 6 and y equal to 0, thus P and Q is at point 0, negative 6 and 6, 0.
The question asks to find tangents that are parallel to the line PQ, and we have two tangents that are parallel to line PQ. Each tangent touches at one point of the circle, and that is here and here. To make it easier, we make a line that connects those 2 points and look for the gradient of the line. These lines are perpendicular to line PQ. So, we will use the formula of M1, M2 equal to negative 1 to identify the gradient of the line based on line PQ. After that, we substitute the gradient and the coordinate of the center of the circle because this line that connects those 2 points passes through the center of the circle. Then, we get the equation of the straight line y equal to negative x. We substitute the equation of the straight line into the equation of the circle. Then, solve and factorize the quadratic equation to obtain the values of x and y. Therefore, the coordinate of the points on the circle C where the tangents are parallel to the line PQ is 0, 0 and 6, negative 6.
So, the first thing we need to do is, we need to determine what are the given. So, I will let the epicenter be at the origin. Basically, the epicenter serves as the center of the circle, and the location of the epicenter is at this point. And the problem states that the earthquake can be felt up to 80 miles its epicenter, so meaning if this is the epicenter, the coverage of the earthquake is 80 miles from this epicenter. Now, therefore, the 80 miles serve as the radius of the circle, and you are located at the point 60 miles west and 45 miles south of the epicenter. So, if I will locate your location using a Cartesian plane, 60 miles west is actually along the negative x-axis, and the 45 miles south is actually along the negative y-axis, because this is the north, this is the east, and this is the west, and this is the south. So 60 miles west along negative 60 and 45 miles south along negative 40 and a half. Thus, this is your location. And the question, if you are located at this point, can you feel the earthquake? So, one way to solve this problem is to get the distance from the epicenter to your location. Then we will compare the distance to the radius of the given circle. If the distance is less than 80 miles, the radius, then it's obviously you are within the coverage of the circle, thus you can feel the earthquake. But if the distance is greater than the radius, 80 miles, then you are out of the coverage of the earthquake, meaning you cannot feel the earthquake. So, the distance between the epicenter to your location using the distance formula, your location is at -60, -45. After substituting the value into the formula, we get 75 miles, and obviously 75 miles is less than 80 miles, therefore, yes, you can feel the earthquake. Now, let's know the real-world uses of circles. Architectural designs. Science use it to compute traditions and planetary craters. Construction also uses circles. Wheels are developed for transportation. Bicycles, motorcycles, and other vehicles that uses wheels. And a lot more.